This is lesson 3.7, graphing absolute value functions. The essential question here is, how do the values of a, h, and k affect the graph of the absolute value of the function given below? Now, our core concept here is that absolute value function is a function that contains an absolute value expression. The parent absolute value expression, of course, is just the f of x equals the absolute value of x, which that graph is a v-shape and symmetric about the y-axis. The vertex is the point where the graph changes direction, and the vertex of the parent here is 0, 0. The domain of f of x equals the absolute value of x is all real numbers. Because remember, domain is the x value. But the range is y is greater than or equal to 0. So for our first example here, we're going to be graphing where we can add a number to the absolute value, or we can subtract within that value. So first off, I'm just going to look at these, and I'm going to make a table of values that's going to help me graph this. But first, I'm going to go ahead and just graph that f of x equals absolute value of x so you can see how it compares to our new graph. So I'm just going to use some values of x that are just going to be easy for me to try to figure out. I'm just going to go -2, -1, 0, 1, and 2. And if I plug those values of x into the absolute value of x plus 3, I'm going to end up with 5, 4, 3, 4, 5. So if I'm going to plot those points, I'm just going to look at this -2, +5, -1, +4, 0, 3, 1, 4, and 2, 5. So you can see that my graph is actually the same, but it's been shifted up 3 units. So now I'm going to do the same thing over here for b here. So now, instead of having it added outside the absolute value, I'm subtracting it from the absolute value. So I'm just going to use some values here again, and I'm just going to plug those in and find out what I end up with. So we're going to go ahead and plot those points. So we've got 0, +2, 1, 1. I've got 2, 0, 3, 1, and 4, 2. So if you notice, what that did was it took our original graph and it shifted it 2 units to the right. So let's try example 2 here. We're asked, and now we're going to multiply that absolute value by something. And again, I'm just going to go ahead and show you what that parent, that original f of x looks like, so that we can compare it to what the new graph ends up looking like. So again, I'm just going to make a table of values so that I can figure out what my q of x is here. So I'm just going to pick the good old -2, -1, 0, 1, 2, which I'm going to end up with 4, 2, 0, 2, 4. So then to plot those points, again, I'm doing -2, +4, -1, +2, 0, 0, 1, 2, and 2, 4. So if you notice, what we're doing is we've taken that original graph and now we've kind of shrunk it and made it kind of a little bit more closer together V. So that's really, we're looking at the domain again is just all real numbers, and the range is still going to be y is greater than or equal to 0. So what about when we do the times a half? So we've multiplied by a whole number. Now we're going to take it times a negative fraction. So I'm just going to go -2, -1, 0, 1, 2 again. And I'm going to end up with the values of -1, -1/2, 0, -1/2, and -1. So I'm just going to go ahead and plot the -2, -1, my 0, 0, and 2, -1, just to show you here that, notice what's happened now? Our graph has actually flipped upside down. In addition to flipping upside down, that would be because of the negative, it's kind of spread further apart, and that's because we took it times a fraction there. So the vertex form of an absolute value function is given in this equation of g of x equals a times x, absolute value of x minus h, plus k, where a isn't 0. This is considered to be in vertex form. That's because our vertex is going to be hk. Any absolute value function can be written in vertex form, and its graph is symmetric about the line x equals h. So then looking here at our next one, we've got the graph here of our first function, and I'm going to go ahead again make a table of values for the function. I've got x and f of x. I'm going to do -4, -3, -2, -1, 0, 1, 2. I usually like to include negatives and positives to make sure I can get everything. And you can go ahead and pause the video and find out those numbers, but I'm going to go ahead and write those down because I've already done that math. And I'm going to go ahead and plot that function then. I've got -4, -1, -3, -2, -2, -3, -1, -2, 0, -1. So you can definitely see where that graph has been. So now, instead of it being at 0, 0, you notice that it was at -2, -3, because we could see that right here. Remember, this was x minus rk, so we'd end up with -2, -3. But it wants us now to compare it to this other graph here. I'm going to go ahead and change colors so that we can see the difference here. But for f of x, g of x, I'm going to again use some values, -2, -1.5, -1, -0.5, 0.5, and 1, which I'm going to end up with -1, -2, -3, -2, -1, 0, and 1. So then, plotting those points, -2, -1, I'm going to go -1, -3, how about 0, -1, and 1, 1. Notice that my vertex now is going to be that -2, I'm sorry, not -2. But this graph has now just moved over 1, and it's skinnier than our original graph because it's really just taking that f of 2x at this point. It's putting in the 2x instead of the x. So let's look here now at our last example here, example 4, graphing g of x in this form. So g of x is just going to have this, we're going to first translate the graph horizontally 1 unit, then we're going to stretch the graph vertically by a factor of 2, and then we're going to end up reflecting it because of it being a -2 out front of the absolute value sign. And then we're going to translate the graph of r vertically 3 units up to get the graph of g of x. So we're going to go ahead and make a table, plot the ordered pairs, and then draw the V-shaped graph. So as you can see, with our black one being the original f of absolute value of x, our vertex is 1, 3. So our original formula has been shifted 1 unit right, shifted vertically 3 units. It's been flipped because of the negative, and it is also shrank and is a smaller v. So go ahead and show me your notes and then get started on Clever.